Welcome to WasmAssembly episode 13. After the last episode where I had my so far furthest away guest on, Thomas Barroso from New Zealand, today I have David Kircos on the show from Boulder, Colorado, who works for a company called Quadratic HQ. Welcome, David.
Thank you, Tom. Thanks for having me on.
It's an absolute pleasure. So, David, you work for a company, Quadratic HQ, which builds a product that is likewise called Quadratic, and that is powered by WebAssembly and WebGL, which is obviously why you are on this podcast, and which in a 2022 blog post you have described as follows. With our modern web app architecture, our grids are as easy to use as Google Sheets, but as powerful as Excel, plus Python and SQL running natively on your computer. Can you just describe a little bit more what Quadratic does and what it is, and just how things work?
Yeah, I'm happy to. So Quadratic is a spreadsheet application that supports programming languages as well as database connections. It's all built in Rust and WebAssembly, and it runs fully in the browser. So our insight was, just like you said, that you can now build a desktop performance app website and have the distribution of a website. You could build a desktop performance application and have the distribution of a website. And that's what spawned us to create this product. And happy to talk about more of the details.
Yeah, cool. So reading on from the blog post, there's another fantastic quote that I just want to highlight. And the person I is obviously the author of the blog post. So you, David. So I called the Wasm WebGL-enabled future a quiet revolution because it's been bizarrely under-discussed. Web developers know about it, but people responsible for strategic thinking around software and computing products are only now beginning to see the possibilities. I fully agree. So this is me talking now, Tom. I fully agree. And hopefully that's something we can change with this WasmAssembly podcast. Then your David, quote goes on, projects that have taken advantage of them are transforming and disrupting their industries, with standouts like DuckDB, which is an in-memory SQL database, gaining substantial recognition. So before we dive into WebAssembly, let's talk about WebGL real quick. So WebGL is a graphics library and an API that allows for fine-grained control over what is rendered on the screen, much more control than what is possible using standard web languages like HTML, JavaScript, and CSS. At Quadratic, you have looked into how this can be used. So I spelunked a bit in your app with Chrome DevTools, and I looked under the hood a bit how you do things. So there's obviously HTML, JavaScript, CSS, and it seems like you're mixing classic DOM rendering with canvas rendering. So the cell grid seems to be canvas rendered, but then like buttons and stuff seems to be all DOM rendered. Could you just explain roughly, and very roughly, this is not about graphics, this is about WebAssembly, obviously, but just that we have the WebGL parts cleared out. So can you explain roughly how this works, how you use WebGL for this case, and just at a high level, give us an overview.
Yeah, Quadratic at its whole is a React app. And so all of the user interface elements that we built, there was no reason to build them in WebAssembly and in WebGL. There's a ton of great libraries for UI elements. And so being able to utilize those for the whole frame of the application, all the menus, all the right-click menu, all these different things that a user interacts with and benefit from that ecosystem was awesome for those elements. And then for the spreadsheet itself, there's obviously a lot of very custom and very sort of pixel perfect interactions that you want with a spreadsheet that were quite difficult to do in HTML. One of the other things that we've done in Quadratic that isn't implemented in other spreadsheets is you can actually pinch to zoom. So if you drag in a larger data set, you can pinch and zoom out and see a large amount of data on the screen at a time. And to deliver that product experience, we had to use WebGL. And that was a big motivation for deciding to use WebGL for the grid in the canvas element of the website. And so that can render a ton of data on the screen. We can control exactly how it's rendered. So we can get really good, smooth pan and zoom, as well as really high performance rendering for the sheet itself.
So just to clarify, the problem here is, like I said, some level of zoom, the number of DOM nodes that you would have to render at the same time. Whereas if you draw to a canvas, it's just pixels. So there's no weight if you draw 1 million pixels, like weight difference. If you draw 1 million pixels, then when you draw 2 million different pixels, I guess, like the most simplified level of how you could describe it. Is that more or less accurate?
There's a couple elements. I'd say One is we wanted a very smooth viewport that feels like you're using like a map or like Figma. And we couldn't achieve that in just using HTML elements with a viewport for zooming in and out. The HTML elements, as you scale them, they don't look exactly the same, and you can't control exactly how the differences work when they're rendered at different scales. With WebGL, obviously, you can just draw exactly what you want to draw, which is perfect for our use case because we're drawing a lot of text, which we spent about the first month of development in Quadratic figuring out how to draw text really efficiently. You could actually zoom out and you could have as much text as like a whole book on the screen at a time, and it would render at 60 frames a second. And so getting that control was great. And then obviously we render a lot of things like grid lines and borders and formatting and that kind of stuff. And we can control exactly how that's sent to the GPU to have really good rendering, which you just don't have that level of control with HTML. You tell it what to draw, but not how to draw it.
So if you remember the episode with Ryan Hunt, where we talked about string built-ins, one of the really nasty things in strings are emojis. So if your emojis are essentially just meaningless pixels by default, your rendering, for example, needs to take care of whatever new emojis that get added to Unicode. So is this something that you just completely handle by hand, or do you have some sort of library that you use that helps with translating text to canvas pixels, for example?
Yeah, we did write our own text rendering by hand. And luckily, Quadratic is a data science tool, so we don't render a lot of the Unicode characters. There's just no reason to in a data tool.
All right, makes sense. Cool. So this was WebGL. I guess there's a ton more we could talk about if we were a graphics-oriented podcast, but this is about WebAssembly. So let's talk about WebAssembly now. And because I had DevTools already open, I just thought, let me reverse engineer how things work likely, and then let's ask David if what I have reverse engineered is completely off or if there's some truth to it. So looking at what Google Sheets does, Google Sheets has the Wasm GC calc worker that is powered now by WebAssembly, and before it used to be JavaScript compiled from Java. So I guess there's some sort of calculation engine, calc worker, whatever you call it, in Quadratic as well. So I guess this is just a given. And David is nodding along. If you're watching this, if you're listening to this, you can't see it, but he is nodding along. So as far I seem to be at least not completely off. So looking at the file names, they seem to be making use of Pyodide for getting Python onto the browser and Python packages with micropip, I guess, also looking at the file names. And you just said it, David. You are a data science package. So obviously there's pandas and numpy that you need. And I'm looking at the URLs. It seems like you're pulling those in for scientific computing. There's ES-build Wasm for bundling and minifying JavaScript code. So if you, and we will talk about this in a couple of minutes, if you test the application, you can run custom JavaScript and Python code. So it makes sense to have ES-build in there. There's some Rust code. I guess you're using that for running JavaScript. So now that I have sort of disassembled your application a bit, I could just ask you. It would have been easier, but also it's more fun to just see what you can just by reverse engineering a product figure out. So what did I miss? Most importantly, how does it all work? Did I overlook something entirely? So David, how was my reverse engineering?
Yeah, that's great. I love that you went through it. Quadratic has quite a few moving parts, so it's a little bit difficult to figure out how they all fit together. In our main web thread, the one that draws the document, we don't try to do too much more than just drawing the page. And that's so the page remains interactive while other things are happening. And so that main thread, most of what it does is it draws the canvas and it draws the UI elements, and that leaves those interactive while a computation is going on. We have a separate thread that runs what we call Quadratic Core, which is a Rust WebAssembly application that is the core engine of the spreadsheet. It knows where everything's stored on the sheet. It runs formulas. It controls formatting, undo, redo, multiplayer, file saving, all of the really important spreadsheet stuff that happens in a Rust application that's in a separate thread. And that just a characteristic of spreadsheets is they only really like one change at a time. And so even Excel to this day, the core engine is single threaded. You can't make a bunch of different changes at the same time because then you'd have undefined outputs and sort of weird behavior. And yeah, you correctly identified some of the other packages as well. So we do run all of the user's code in their browser on the front end. So if you add a Python cell in Quadratic, for example, that will actually be evaluated on your own computer. And that enables it to have a really fast response time. It's really great when you can put some data on the sheet, write a Python script on it, and press play and see the result in just a few milliseconds. It doesn't have to go to a server, spin something up, install stuff, get a result, and send it back to you. It just happens really fast. So that was partially for user experience, partially just to keep everything on the front end. It's a lot simpler from an architecture perspective than us spinning up servers every time someone tries to run code. And I think it's sort of a testament to what's possible in the browser now. The browser, went from this sort of light, hey, it can draw HTML, it can run small scripts, to the browsers today pretty much a full operating system. You can run full applications like Figma, for example, built this Adobe competitor that just runs in the browser. I don't think people would have thought that was possible 5 or 10 years ago. And it wasn't. It wasn't possible 5 or 10 years ago. The browser's changed a lot and it's become a lot faster and a lot more powerful. And so being able to offload a lot of that computation to the front end, I think just creates a much better user experience.
Yeah, absolutely. So just if you've never used Quadratic, the way it works, they have this concept of code cells where you can say like, hey, cell C1 is a code cell. And in this code cell, I have, for example, a JavaScript function running that does some sort of calculation. If you used, for example, Google Sheets online, it does have a similar concept where you can say, I have, for example, custom formulas, and then you open an editor, run or write a custom JavaScript function that does something, whatever, like reverse a string, just to come up with a stupid example, and then you get back the result. All of this is running like on Google's cloud servers, but here, Quadratic have reversed it. They just ship the runtime. So you can run Python, you can run JavaScript directly on the client, which is pretty powerful. But then, of course, once you do that, you want to be sure that everything is properly sandboxed so that people don't do funny things with untrusted code that you just run on their computer. And this is where WebAssembly then comes in. So looking at the infrastructure there. So there's obviously you didn't invent running Python in the browser, or you didn't invent running JavaScript in WebAssembly or something. So looking at the ecosystem where you have a bunch of options, how easy was it to get from, hey, let's do this, to the actual implementation?
Yeah, a big difference between Quadratic and like Google Sheets, for example, is Quadratic. We took Python and JavaScript and we made them as native as formulas. So just in the way you can press equals and start to put in a formula, and Quadratic you can press / and start to put in Python code. It's a native language of the spreadsheet. And the reason we did that is because working with data today involves much more complex analysis than it used to. And having access to languages that can solve a much wider range of problems in a much more elegant way is really excellent. Instead of having to sort of deploy that code somewhere else and then kind of run it on the side, it's just a native language that you can work with your data directly in the sheet. And to deliver that experience to users, the ecosystem, it has evolved a lot since when we started Quadratic. Pyodide has become a much more mature Python runtime to run Python in the browser and WebAssembly. And we thought we'd have to move to the cloud a while ago for some of our more advanced use cases, and slowly Pyodide's kind of gotten good enough for more and more of those use cases, and we've put off moving code execution to the cloud even longer than we thought we had to. So it's been great to see that ecosystem mature, because I think it makes products like Quadratic possible and a really good experience, especially now where a lot of our new users are people who haven't necessarily successfully written code before, and they're using AI to generate code, be able to work, like to be able to see their data on one side, some code on the other side, and to just be able to run it in an environment where they can press share and someone else can load it on their computer and it is running the same environment, which I think was sort of always a core pain point of using Python for working with data, right? Your interpreter would be a different version, your files would be in a different location, and just because it worked on your computer didn't mean it would work on anybody else's. And so being able to package that all up in the browser and ship it in a way where if it works on my computer, it'll work on yours, delivers a really awesome user experience.
Yeah, absolutely. So talking about files for a moment. So if you have Python, obviously as a full programming language, you can work with files, you can open files and so on. But then running in the browser, you obviously are constrained by the things that you can do. Just for example, by limitations around cores. So you can't just open random files from anywhere. So again, with DevTools, I found out that you run some sort of CORS proxy for people, where you can remote load any kind of whatever, a CSV that is somewhere on a server, so you can load that and then process it in JavaScript, in Python, and whatever. Are there any limitations like that where you wish the browser would be more capable and less secure in a way, like in the sense that security could be a limitation for the use case that you're trying to realize on the web?
Yeah, good catch. CORS was one of the most annoying issues, I would say, with running it in the browser. A lot of people want to use requests with Python, the requests library, which assembles socket connections at a fairly low level. And so that library doesn't work in the browser either. There's no way in the browser to use sockets directly. You have to use the JavaScript fetch, or basically you have to use the web APIs. You can't use the socket APIs directly. And so there's a shim in our package as well. So if you try to use Python requests, it'll convert it to a browser-friendly request for you. And that does have to go through a quadratic proxy. Otherwise, your browser will block the request. That was one of the specific issues for running Python in the browser. And one of the other ones is just package compatibility. And this isn't a Pyodide issue. It's more of just a lot of packages don't support WebAssembly. And for some packages, that makes a lot of sense. Like for some like ML model that requires a graphics card to work or something, it doesn't make sense for them to support WebAssembly. But a lot more packages have started supporting WebAssembly since we started. And a lot of the ones that are most important for working with data do. So like pandas, numpy, scipy, matplotlib, like a bunch of or plotly, a bunch of those support it now. So with that support, there's kind of enough to do great data work in the browser. As long as you don't need, some high performance external package, it should work pretty well.
Right. So if you take some massive data science task that the user wants to perform locally on their browser, and let's assume there was just some Python package that is suitable for whatever you need, so crunching massive amounts of data, and this thing would work natively, like if you execute it directly on a computer in Python, would depend on, let's say, a temporary file of, typically when people use it, of, let's say, 5 gigabytes, right? Is this something that you can support in the browser? So does Pyodide then sort of have some sort of shim that uses, let's say, in the browser, the origin private file system and falls back to that? It just makes it look as if Python were actually creating a file on disk? Or how do things like that work? Or is this where you just say, oh, we've hit a compatibility issue, we just can't work around this?
It depends on how wide you want it to be able to be supported. I think if your user has a relatively new computer with a good processor and memory, and they're willing to set the browser to be able to use more memory for a thread, you can do stuff like that. As far as I know, the default is about 2 gigabytes of memory that the browser will give a specific website. And so we try to stay under that. And most of the use cases for our users stay well under that. Most people are pulling in some data that might be tens of thousands of rows of data or hundreds of thousands of rows of data, writing some formulas, writing some Python to work with that data, and then writing some more code to visualize it. And so that stuff kind of falls well within what's possible within the browser. And by the time you're getting into stuff that doesn't fit well, you're kind of doing something that doesn't make all that much sense in a spreadsheet to begin with. If you're bringing in, 10 or 100 million rows of data into a spreadsheet, maybe that's not the best way to go.
Yeah, so there's this funny saying, your big data fits in RAM, and then your big data is actually just a Google spreadsheet. And I guess the truth for this is somewhere in between, where you have, your specialized data science-y kind of spreadsheet application. But then, at some point you hit just memory limits, CPU limits. What is the limit that people actually hit most typically? Out of memory, out of like CPU is too slow? What are the limitations that people run into typically?
One of the limitations that we see is just internet speed. And the quadratic bundle is a fairly large package. If you want to load the website and load the Python interpreter and actually be able to run and execute code, it's over 100 megabytes, which isn't super atypical of a web application like Quadratic. Like Figma, for example, is also 100 megabytes. It's a similar size, but to download that on a slow connection can be very slow. And so the limitation that we're seeing is actually getting the whole application to users. Once you've loaded it once, your browser will cache a lot of those pieces and they don't change often. And so future loading of the website happens a lot faster than the initial load, but that initial load can be pretty slow. And that's one of the limitations that we're looking at, kind of reducing all the packages, reducing what's sent, reducing what's needed to get the first render, that kind of stuff.
Makes sense. So before we talk about application size and loading and bundling and stuff, one more question around limitations of WebAssembly. So there's probably some proposals that could be interesting for you, like memory 64 for addressing large amounts of just memory. Is this something that you have been limited on, or where you say like, hey, if more browsers would support this, we could have whatever. Have more cells that we could address to something like increase the limits that you enforce on your application, or are you not limited by that?
We're building an application that we want to work on the widest group of devices possible. And so the new technologies are exciting, but until they're widely supported on a wide variety of hardware and a wide variety of browsers, we don't really consider using them, and we'll spend a lot more time just optimizing our own application. I think there's still a lot more performance we can get out of Quadratic by optimizing our own code that doesn't require new browser APIs to get more performance out of the app.
Gotcha. Yeah. So this is also a pretty classic approach for web developers. Until something isn't widely supported, people won't really use it unless they really, really can't get around it. But yeah, so you just mentioned before, downloading the application is 100 megabytes of data. So this is obviously across everything. So there's JavaScript, CSS, web fonts, obviously the WebAssembly, there's images and everything. So it's a lot of data, but it gets cached, obviously. But then looking at JavaScript, we can classically bundle our JavaScript. We can dead code eliminate it. We can tree shake it and so on. With WebAssembly, and especially when you use more or less ready-made packages like Pyodide, like we had it before, numpy. So these kind of things that people just publish as libraries, bundling them all together and then dead code eliminating and stuff, it's not really a thing. There's a proposal in the WebAssembly world, which is the ES module integration that in the future hopefully should help with some of those needs where people have like, 5 different WASM libraries that I want to bundle together. And then ideally, if those 5 different WASM libraries have some overlap where they all happen to implement an X function that does X, you would only have this once, not have each individual library ship their own version of this particular thing. So is this something where you were actively looking into standards and be like, hey, I wish we had this already? Or is this just something where you say like, yeah, caching is working with this over time, and for people it's a one-time download cost and that's it?
Yeah, it's a few questions in there. I think we're in a phase of we've added a lot of features recently and our package size has grown. And now we have to kind of take a look and see, okay, how can we load it more efficiently? How can we lazy load part of it? I think Quadratic's kind of in that sort of cycle right now of like, we just added a ton of stuff, so it grew a lot. And I think that we're for sure interested in ways that could help us, ship less of the WebAssembly package at the initial load and more as it's needed. You can kind of achieve this today by shipping multiple separate applications that can potentially have shared libraries or shared code. There is quite a bit of overhead in that, actually, though. Like the minimum Wasm application is a couple megabytes. So there's when you're building from Rust, when you're building it with the quadratic core that's needed. So we could split it out into a couple of different Wasm bundles, and we do. We actually have 2 in the application. There's one that does the core spreadsheet and another one that helps the renderer that runs in a separate thread, and those are loaded separately. We could potentially split it out more that way. And I think, a huge part of our package is Pyodide. It's the Python interpreter. And so there's not a whole lot we could do to reduce that load, except for not change the library very often, because then there's a much higher % chance that our users will hit the cache.
Yeah, makes sense. So you talked about AI briefly, and one of the first things that I did when I tried your product is, of course, break it. So I'm not a great Python author or anything, so I just discovered the AI integration that you have ready-made for the code cells. So I was like, okay, so let's just give this AI a spin. And you integrate with Claude and with OpenAI. So you ship with, I think by default, you get Claude 3.7 right now. So I just told it, hey, write me a function that, I think I kept it really simple. So I said, hey, write me a Python function that adds two numbers. And of course, I could still do that by hand, but for a test, I just asked AI to do it. Okay, I got this function and it gave me some examples. So 1 + 2 and so on. So as I said, I tried to break it. So I was like, hey, let's give this an instance where it tries to add numbers that Python can't handle with. So like big int +1, for example. So I just said, hey, AI, give me 2 input parameters that will overflow whatever Python can do. And it handled it well. So it showed me the, I think your UI just shows hashtags. So broken, hashtag. There's probably a better way of telling the user what has happened there. And there's probably some term that people use in the spreadsheeting world for this kind of overflow error. But I was very positively surprised how well it worked. And of course, I played with the model a little more, gave it some real use cases. But then at one point I was like, hey, wait, this is one of the only ways where they still need to go to a server. And we've seen people do amazing things now client side. So my question was, with WebGPU support and with WebAssembly powering a lot of those models running right in the browser, is shipping a local LLM something that you have considered for one of the upcoming versions of Quadratic?
Yeah, I think it's really cool to see people use the large language models in Quadratic to write code, and in some cases, again, people writing code for the first time. We had a user the other day that it's a salesperson. They came in, they dropped some data, and they wanted a fuzzy match between company names. You know, company names sometimes have like LLP or limited liability partnership, or there's all these different ways of writing them down. So they wanted to do a fuzzy match between these two lists, and they just asked the AI to do it. It gives like 15 lines of code to do a fuzzy match, and they were able to do the match. And I think that type of experience is really only possible in Quadratic because we support code and because we're using the latest large models. We've played around with AI a lot in spreadsheets over the last couple of years, and the models have only recently started to get good enough to be able to orchestrate spreadsheets. There's a lot to think about, right? There's multi-dimensional positioning of, hey, where's that value that I put on? How do I reference that? Where does the code live? Where does the output of the code live? There's a lot to reason about when adding code and formulas and values into a spreadsheet. And really only the latest frontier models are good enough to do that in a way that enables people to build spreadsheets just using AI, or to build spreadsheets with code who don't code. And we've thought a little bit about, can we run these models locally? What can we do locally? And it again comes down to like compatibility. It's like, if we want a lot of people to be able to experience this, we can't assume that they have any specific type of hardware. And to be able to run a model powerful enough to work in a spreadsheet is a very small fraction of computers that are out there. And there might be a day in the future when that fraction is large enough where we're like, great, let's run it locally. But we're just not there today. And I think it'll be really interesting to see how that develops, because I'm sure there are other things within our tool where it could make sense to run the model locally. If we want to name a function or something, running a small model to do that really fast and give really, really quick output to, hey, just come up with a name for this Python snippet or this file or whatever it is for the users to save them, 2 seconds. That type of thing I think could be possible in a local model. And we're definitely going to be exploring those types of things more in the future.
Yeah, so there's, I think, 2 entry points for AI. One is in the code cells where you are isolated in that particular code cell. So you can say like, hey, write me a function that does X, and it works super well. But then you have also the like global spreadsheet level where you can say like, whatever, look at columns A to Z and chart me this, right? So it can be really free form. But then when you have big sheets, at one point, I guess you hit some sort of limitations with the context window length, because you somehow need to get all the locally available spreadsheet data into the cloud and then get the result back. Is that a problem where you just are waiting for models to become even more powerful, or is this just something where you say like, that's the limitation so far? As a human, you can only ever also work with the things you can still see on the screen, and everything else probably even would exceed the human context window, or like, where are you there?
Yeah, the left global chat in Quadratic can orchestrate a bunch of different things in the sheet, and it understands a lot of different things that are in the sheet that's in the context. And we believe that people use spreadsheets when they want to understand something. And so someone doesn't want to type something in, come back 30 minutes later, and have a sheet that's so big it feels like someone else just sent it to them. And then it's just like, decoding someone else's spreadsheet, which is really difficult. So we try to build the experience where the human's in the loop. There's feedback pretty continuously. This results in a much better spreadsheet, and it also results in the person that's using the tool understanding the data that they're working with, which I think, again, is why people use spreadsheets. You're trying to understand something. And so there's a lot of particular things we do to get the right context into the tool and give it the right tools to be able to take action on the sheet. And so we don't just send the whole sheet. We send summaries of where things are on the sheet, what they look like, what their names are, how to reference them, that kind of thing. And we're working towards actually adding a tool call to the model itself to be able to fetch more data from the sheet. So if it's trying to understand something better, it can actually ask for more context and get that context. And I think that's what the model will have to look like for us, beyond just like sending the whole sheet to the LLM. Right now, the LLMs would not be very good at that, and that would be very inefficient. It may be the case in the future where that's just what you do, right? You have it all in a vector database or something, and it's just able to access it with every call. Or we just get better at figuring out how to send it the most appropriate context. Like you said, what's in the viewport? If the user asked about something that's not in the viewport, being able to give it a tool to be able to, hey, give me more information, that kind of thing. Yeah. And then obviously controlling what it can do in its output, because we want it to be able to take actions that save users time, but still are small enough to where the user can understand them and see, hey, it did this, it did this, it did this. I understand what's happening in my file. I still understand the data. This is not just like asking someone else to build a spreadsheet, but this is me building one just a lot faster and in a lot less frustrating of a way. You're running into fewer like, what formula is that? How do I debug this error? You're not running into those edges as much. You're just kind of able to continue on your analysis. Just, I like to say at the speed of thought. Just you're thinking it through. You're talking to the model. It's taking actions, and there's less blockers. There's less. Now I got to jump over and go and look at the documentation or something. There's less of that.
Yeah, absolutely. So I still remember at the very beginning of my career, I was working with a team that did a lot of work in back then Microsoft Excel, so it's completely running natively. And back then you were absolute king if you knew how to do a VLOOKUP. So that's something that a lot of people just don't get into their heads. So with AI assistance, of course, that's a lot easier. Yeah, cool. So I want to talk about the code cell concept a little more. So right now you support JavaScript, you support Python. But in the end, this a little bit hints at what we have seen maybe in the episode with Steve Manuel from Xtism. We had after that an episode with David Mitten, who talked about the component model in WebAssembly. So what if, rather than letting people, let's say, add a JavaScript library that does X, like plotting, for example, what if they could just say like, hey, I have this amazing Swift library that does this kind of chart that I really, really like, and I want to get that into Quadratic. Is there a way where people could be like, hey, I just have this thing that I compile to Wasm, or that even you could compile to Wasm and then run it on their behalf? Is this something that you're thinking about, or is it more like, you have Python, you have JavaScript, which means you cover, let's say, 80% of the market, and it's just good enough because, you have a lot of other priorities to fight with. So where are you on that scale?
Yeah, we also support SQL, so you can also connect databases and outside data sources. Uh, and I think that it's a spreadsheet, right? Like the purpose of the tool is to be able to package data and some analysis in a way where I can send a model to somebody else. They can play around with it, tweak it, see how it affects outputs, that kind of thing. And I think people have a tendency to, try to do crazy things in spreadsheets, right? Like people have built Doom in a spreadsheet. People have built all sorts of crazy things in spreadsheets. And um, I think we it's a free form tool. What our users do with it is up to them, not up to us. And I think we want to build the best environment for doing that. And so if there's ways to enable more custom stuff that can be packaged with the sheet and distributed in a way where you keep that magic of, hey, it worked on my computer, it'll work on yours, then yeah, we'll look in. We're definitely interested in adding that type of flexibility to the tool, but we don't want to add anything that breaks that paradigm. And I think that that's like a critical part of what makes a spreadsheet so great is I can work on it on my computer. I could do something quickly, create something useful for understanding information and understanding data, and I can send it to you and you can use it. And the second that you break that paradigm, I think it loses a ton of value. So that's another awesome thing about WebAssembly, right? That you could create these custom things that are packaged and sent along with the sheet that will run exactly the same on different computers. So yeah, we're definitely open to that.
So history-wise, it started, I think, with Python, which makes a little sense if you come from the data science corner of the web. And then you added JavaScript. What is the most requested the most requested programming language after that right now, if you can reveal?
If you look at like programming language popularity, like overall, about 1 billion people use Excel formulas. So it's the most popular programming language in the world by a factor of 10. And then there's JavaScript. But oddly, people don't use JavaScript very much for data analysis. JavaScript is used for, websites, servers, all these sorts of different things quite a bit, but it just isn't used for working with data all that often. And then as you get on the list, then there's Python, which is the primary language people use outside of Excel formulas for working with data. And lower than that, the most requested ones that we get are like R, which is interesting, and then obviously other SQL languages.
Yeah, so luckily R is already available for WebAssembly. So if you wanted to add it, it would probably be relatively easy, including some graphics support for, like charting and stuff that R obviously also comes with. But yeah, you just hinted at the SQL integration. I wanted to talk about another big WebAssembly project that actually we at Google have helped fund. So we worked with the SQLite folks and tasked them to port SQLite to WebAssembly, which they did. And so right now you offer MySQL, Postgre, I think Microsoft SQL Server something as integrations. And you before hinted at like limitations of data, like, right, it's a spreadsheet. So people don't work with gigabytes of data in a spreadsheet. But like, if you imagine SQLite is a database that can easily handle gigabytes of data and it can run in the browser. People do download gigabytes of data, like not often, but like if you want to, you can. So have you ever thought of integrating SQLite WebAssembly running in Quadratic? That would then, I don't know, pre-filter through some smart SQL querying your gigabytes of data and turn that into megabytes of data, hundreds of megabytes of data that you can easily process in Quadratic. Is this something that you have considered at all, or is this like right now mostly things on the server, like integrations with people's SQLite server or SQL server or Postgres server, or like where are you there?
Yeah, we are thinking about it because I think people do want to be able to bring some data into a spreadsheet and write a SQL query against that data that isn't in some outside database, but it's just in their sheet, and be able to use the SQL language to create a query against that because that's what they're familiar with. And so we've been looking at both SQLite and DuckDB, both which have WebAssembly runtimes, to be able to add that feature in the future. So I think that would be a really useful feature, especially for people who use SQL a lot.
Awesome. Well, that's pretty exciting, especially because I'm friends with the DuckDB creator. So if
Awesome.
Hannes hears this, yeah, so that's some exciting new use case probably for DuckDB. Cool. So one final question. This is maybe a little bit more about your business model. So obviously you have AI integration, you have some enterprise features, you have cloud intelligence and so on. But when I looked around on your GitHub organization, to my surprise, I found Quadratic self-hosted. So you can actually self-host for three users the entire Quadratic, or like I guess not the super entire, but a big part of the Quadratic offering. So what is it? What people get? Is this like a stripped down version? How local actually first is this? What you get there?
Yeah, Quadratic is an early company, and so I'd say we're still figuring out our business model in terms of all the specifics. But for a lot of people who are using a data tool within a larger organization, data security is the most important consideration. It's table stakes we can't share our company data with someone else. We have to be able to host the tool ourselves, and so Quadratic can be self-hosted, and you can do up to 3 free users, and then from there you have to contact us, and that's sort of an enterprise like relationship. And then for our cloud-hosted version, we have a generous free tier. We're always going to have a free tier. It's important to us that people can just come and use the tool and maybe do something create a spreadsheet for personal finance or something like that, and learn how to use the tool and get value out of it, and really only start paying for it once you've started to use it for work, started to use it a lot. And so we're figuring out exactly what those tiers look like and sort of what things fall into what tier, but we're committed to continuing to offering a great free tier. And then the self-hosted tier is really targeted towards enterprise. So Quadratic is a complex application to deploy, and it's useful that deployment type is useful for people with strict data security requirements.
So when you say that, it means like there's absolutely no phoning home. You're entirely just living within your Docker container that you download from the GitHub repo, and then you can have everything running entirely local without any Quadratic server in between.
The only thing that it phones home for is to check for a license key. That's it. So yeah, the completely air gap all of your data, all of your code, everything in a self-hosted environment.
That's pretty cool. Yeah. So yeah, this brings us to the end of the show, which means this is the next section, which is WASM but not. So David, when you instantiate streaming on any of your streaming devices, what is it that you currently watch or listen to?
My wife and I have been watching Yellowstone lately, but we're we live in Boulder, Colorado, so we spend a ton of time outside, and it's cool to see a show that's like in the Mountain West.
Nice. I have not heard about this show, so can I briefly describe what it is about? Is it just about nature, or like is there crime involved, or what makes the show?
Yeah, Yellowstone is a family that owns a ranch in Montana, and all sorts of people are trying to take their land, and they're fighting them off in all sorts of different ways. There's crime, and it's pretty violent, honestly. Uh, yeah, there's also scenes of just people riding horses through the Rocky Mountains and that kind of thing, fishing, all that sort of stuff.
All right, cool. So last question. If there's one thing that you could local get, as in something that you do, and then global set, as in something that you wish everyone else did, what would it be?
I don't know. I think spending more time outside is a great thing. Like one of the things about living in Colorado is most people out here spend a lot of time outside, and I think I do some of my best thinking when I'm on a walk. I'll feel like struggling with some sort of programming implementation, and I run a walk, and I'm like, oh yeah, that's the answer. I think a lot comes to you when you're able to just kind of go on a walk and think things through.
Oh yeah, absolutely. So sometimes when I'm stuck on something, I go on a run, and then during the run, I just let my brain go loose, and all of a sudden it's like, oh wait, here's the solution. Cool. So thank you very much. If people want to reach out, if people want to follow your work, do you use any of the social networks? Are you on LinkedIn? Do you have email? Do you want to be contacted over whatever, Instagram? How can people reach out if they have questions?
Yeah. So Quadratic, we're on X, we're on Twitter at Quadratic HQ. You can find us at quadratic.ai, and Quadratic's free to use. So if you have any feedback on the product or anything, there's a big feedback button in the top bar. Press that and it'll send a message to our team Slack, and we read all of them, and we respond to any of them that are worth responding to. So yeah, thank you.
Cool. So there's no AI behind it. It's just actual human beings that you reach.
It's us, yeah.
Perfect. Cool. So talking about reaching actual human beings, thank you so much for listening. Thank you for watching. Thank you, David, for coming on the show. And yeah, if you are out there and you have something interesting to say about WebAssembly, about how you use Wasm, definitely also reach out. And with that, thank you so much again for listening, for watching. And thank you, David, for being on the show today.